we'll be exploring the concept of compounding or compound interest a little bit more. So compounding or compound interest. Okay, so in the previous video when we explained compound interest, what we mentioned was compound interest is basically whenever you calculate interest over a certain period of time, the next period the interest also earns interest. So basically you are adding the interest to the principal amount and then calculating interest on the total amount. So that means that the interest also earns interest as we go forward. And as the time progresses, the amount of interest that you earn increases exponentially. So how does it compare to like simple interest? So if you want to compare compound interest and simple interest, how do you what is the difference between those? Let's try to find that out first. Let's say you're given $10,000 at 5% per year compounded annually. POU compounded annually. Compounded annually means that the interest is calculated at the end of every year. Okay, so let's say this is compound interest. Okay, and then this is simple interest. Okay, so compound interest is defined as future value is equal to present value plus 1 plus r raised to t, where r is the rate of interest, which in this case is 5%, and t is the time frame, or the time that you calculate the interest for. And present value is $10,000. So, and for simple interest, future value is equal to present value plus principal amount into r into t. So principal amount is 10,000 always. In this case is 10,000 and rate of t. So let's say for the first year, so future value is equal to 10,000 into 1 plus 0.05 raised to 1. T is 1 in this case because we're calculating the interest at the end of first year. So this is 10,000 into 1.05, which is 10,500. Okay, so at the end of first year you have 10,500. Okay, now second year, future value is equal to present value is 10,000 plus 1.05 raised to 2, 1.05 raised to 2, which is equal to 10,000 into 1.1025, 1.1025, okay, which is equal to 1125. Okay, so at the end of the second year you have $11,025. Okay, third year, future value is equal to 10,000 into 1.05. 1 plus 0.05 is 1.05 raised to 3. So this is $10,000 into 1.15762. You probably need a calculator to calculate this. 1.15762. So 1.05 raised to 3 is 1.15762. So this is equal to 11,576.2. Okay, so that's the future or the amount at the end of the third year. So if you put in $10,000 in a CD or a fixed deposit in bank at 5% per year, at the end of 3 years you'll have 11,576 if the interest is compounded annually. Okay, now how about simple interest? So future value is equal to present value is $10,000 plus P is 10,000 into 5 by 100, which is the rate of interest, into 1 year. So these two cancel out. So this is 10,000 plus 5 into 100 is 500. So 10,500. So at the end of first year, the interest calculated based on compound interest or the simple interest will remain the same because it's only 1 year and you have calculated the interest at the end of the first year. Now, what about second year? So future value is $10,000 plus 10,000, that's the principal amount, into 5 by 100 into 2. So this is equal to 10,000 plus 1,000. Okay, this to cancel 100 into 5 is 500 into 2, 1,000. So $1,100. So you'll see that if you calculated the interest based on compounding annually, you will have $25 more compared to if you calculated the interest, simple interest. So when you compounded the interest at the end of the second year, you'll have 11,025, but by simple interest, you'll have $11,000, $25 more. Now, how about if we calculated the interest at the end of third year? Future value is equal to 10,000 plus 10,000 into 5 by 100 into 3. These two cancel out. So this is 10,000 plus 1,500. So this is 11,500. So again, as you can see, like at the end of third year, if you just use simple interest, you'll have 11,500. But with compound interest, you'll have 11,576.2 or $76 more if you compounded the interest. And this $76 extra is the extra interest that you earn on top of the interest. So that's the difference between the simple interest and compound interest. But as you can see, the difference is not that much. If you look at the amount, it's only $25 in the first year and $76 in the second year. But what happens if you go like in future years? Will the difference increase? Obviously, the difference will increase, and we can find that out. Let's take a look at that. Calculated the interest over a course of 40 years for $10,000. So we have the principal amount. So we have the principal amount as $10,000 at 5% interest. So what I've done is I've calculated the interest, simple interest and the compound interest over a course of 40 years. The green line represents the simple interest and the orange line represents the compound interest. Okay. So as you can see, as the number of years progress, the compound interest increases exponentially pretty much. So at the end of 40 years, the compound interest will be $70,400, while the simple interest will be $30,000. So there is a huge difference of about $40,400 at the end of 40 years, which is a huge amount. Now, if you look at just 20 years, the difference is about, for the compound interest, it's $26,533, while with the simple interest, you'll have $20,000 at the end of 20 years. So the difference is about $6,533 at the end of 20 years. At 20 years, okay. At 20 years, the difference is about $6,533, but at the end of 40 years, the difference is about $40,400. So which is a huge amount. So as you can see, the compound interest, as we increase the number of years, or if you keep the amount, as we keep the amount in deposit for 40 years, if the amount is compounded annually, the amount of money that you will have is far more when you're compounding compared to when you do it with a simple interest. And this is what is called as the power of compounding. So basically, if you calculate the compound interest, the money multiplies at a much faster rate compared to just doing it in a simple interest format. Okay, so this is what is called as a power of compounding. Okay?